Will I share my screen?
We're live.
Okay. Can you all see my screen?
Yes.
Yeah.
Okay, cool.
All right. Hello and welcome to today's Wikimedia Research Showcase. My name is Janelle and I will be your moderator with the help of Martin Gerlache, who will be on IRC and YouTube live stream for your questions. We are both part of the research team at the Wikimedia Foundation, and if you are curious about our work and what we do, please check out our website, research.wikimedia.org. Today we will be learning about some research in human machine learning, an area that has garnered a lot of interest in the past decade and has proved to be really crucial for machine learning algorithms for applications requiring high precision. To cover this theme, we are very glad to host two great speakers. Ji Yang will present a Bayesian framework that leverages mechanical Turk crowdsourcing in order to identify social media influencers. Ji is a research scientist at Amazon, and this work was published at the Web Conference 2020. Without further ado, Ji, the mic is yours.
Thank you, Janelle, for the introduction. Hello, everyone. I hope you are all doing well, given the context. My name is Ji Yang. I'm an Amazon research scientist. In this presentation, I'm going to introduce our work on open-ended answers aggregation in crowdsourcing. So the work was carried out in the context of finding social influencers, but the method that we developed is actually applicable to other crowdsourcing tasks, and hopefully also applicable to some of the projects in Wikimedia Foundation. This joint work with my former colleagues at the Exascale Info Lab in the University of Freiburg, Ines, Mora, and Philippe. So let me give a bit more context on the problem. Finding social influencers is very important as it allows us to reach a new audience that could be very helpful in many tasks. For example, research has shown that 40% of Twitter users have made a purchase as a direct result of seeing a tweet from an influencer. So brands are trying hard to connecting to influencers for product promotion. Identifying social influencers could also be very important for fundraising. For example, the followers of a fashion influencer, Chiara Ferragni, raised over 2 million euros in the fight against COVID-19 in half a day after post on Instagram, which is super fast. Identifying influencers could also be useful for presidential election. And we have seen that US presidential candidates, they reach out to influencers because those influencers allow them to reach to audiences that they might not be able to connect to otherwise. So we have seen that influencers could be very helpful, but actually not all of them can serve all those different purposes. So we distinguish between two different types of influencers, macro influencers and micro ones. Macro influencers are those that have a big number of audience, like the fashion influencer that I mentioned before, Chiara Ferragni. They often have partnership with luxurious brands. Micro influencers, on the other hand, they have fewer audience, but they tend to keep a close relationship with their followers by communicating through, for example, comments. Because that they have this close relationship, it allows them to be more relatable and thus, in many cases, more convincing in promoting products. And this is why we are currently getting more and more interested in identifying this specific type of micro influencers. There are different methods for identifying social influencers. One main approach relies on the properties of the network among users, such as node centrality or authority score obtained via algorithms like PageRank. The problem here is that it is now getting more and more difficult to access the network structure due to the privacy issues. The other type of method is to train a machine learning model on social features, such as number of followers, followees, and the content of the tweets. But in order to identify micro influencers, we need to collect a large number of expert labels because micro-influencers can be very different from each other. And collecting a large number of influencers could be very time-consuming, even for experts. So what we did is very simple. We used crowdsourcing because it offers a fast and economical way to collect a large number of influencers. The idea is very simple. We ask the crowd workers to name influencers that they know in a predefined domain. So essentially, it is an open-ended task where workers can give freely names that they know in social media. So by doing this, it actually allows us to exploit the broad knowledge of crowds. Note that individual crowd workers might know only just a few influencers, but together they can provide us with a big pool of social influencers on the aggregated level. So this type of method is actually very useful to collect micro influencers. But using crowdsourcing for collecting influencers can be very challenging because workers have different reliability due to their different levels of expertise, for instance, and maybe the different level of addiction to social media. Another challenge is that workers, they only provide us with influencers that they know. So actually all the answers that we get are deemed as relevant by workers. This means that we would not have negative labels, negative examples to train our machine learning model. And finally, because workers can give names freely, in the end, we might get a very big pool of answers, which could further complicate those aforementioned problems. So how can we infer the truth when it comes to open-ended tasks? Well, there are several questions that we need to consider. And to see that, let's first look at an example. In this example, we have 4 workers providing candidate influencers. For example, worker 1 named candidate influencer I1 and I3, and worker 2 named influencer I1, I2, and I3, right? So how can we infer which candidate influencer is the real influencer? Well, given this context, there are several questions we need to consider. The first one is that are answers given by more workers more likely to be correct, which is quite intuitive, right? For example, here, candidate influencer I3 is named by 3 workers, while candidate influencer I4 is named by only 1 worker. Well, this might be true that I3 is more likely to be a real influencer than I4, but it could also happen that those influencers who all named I3 could be not reliable at all, right? So we have the need to model worker reliability. But how can we do that when all answers are deemed as positive? And the last question that we also want to consider is, given that there are different workers may have provided different numbers of candidate influencers, can we differentiate our confidence in our inference of worker reliability when they have different number of answers? Intuitively, we might be more confident in inferring the confidence of workers with more answers, but how can we do it in a rigorous way? So in this work, we show that machine learning models, when used together with a small number of expert labels, can actually be very useful in inferring worker reliability from those answers that are all deemed as relevant. And we propose a human AI collaborative approach, OpenCrowd, for open-ended answers aggregation. OpenCrowd is a Bayesian framework that allows us to quantify our uncertainty in the inference of worker reliability. We derive an efficient learning algorithm to estimate answer quality and worker reliability, and we demonstrated the effectiveness of our proposed framework on 2 domains. So now let me introduce a bit how the framework works. It takes as input worker answer matrix that represents the naming relationship between workers and answers. And meanwhile, it extracts social features for those workers. And then together with some expert labels, the framework first trains an initial version of a machine learning model that predicts the quality of the answer from the social features. The framework then iterates between 2 steps. In the E step, it estimates worker reliability and answer quality using the output from the machine learning model. And then in the M step, it updates the parameters of the machine learning model using the newly inferred answer quality. And in the end, we get the labels for all the candidate influencers. Now let me focus on this part where we estimate worker reliability and answer quality. Okay, this is going to be a little bit mathematical, but I will keep it to the minimum. So we define worker reliability as a random variable Rj that follows a beta distribution. Now defining it as a random variable would allow us to quantify our uncertainty in the inference. And meanwhile, we define answer quality as another random variable Zi, which follows a Bernoulli distribution. The parameter of the Bernoulli distribution, which is theta here, is actually the output of the machine learning model that predicts answer quality from the social features of the candidate influencers. And finally, we define the annotations as a variable that is conditioned on worker reliability and the answer quality. By doing this, we connect model training with the inference of worker reliability. The likelihood of the annotation is defined in a way such that a reliable worker has a higher likelihood of naming a real influencer. And then we derive a principled optimization algorithm for parameter learning. So as I mentioned, the algorithm iterates between the E step and M step, right? And the E step infers answer quality and worker reliability, and in the M step, we learn the machine learning model. What I want to emphasize here is that we prove theoretically that both answer quality and worker reliability can be updated incrementally from their estimations from their estimate in the previous iterations. So this makes the learning algorithm actually very fast, and the whole algorithm takes little extra time compared to the general setting of training a normal supervised learning algorithm. Okay, now let me briefly show you the incremental updating rule in the learning algorithm. This is going to be very quick. If you want to learn more about the details, please refer to our paper. So recall that here we have parameters of worker reliability, alpha j and beta j, and we have the parameter of the answer quality, which is theta I. The updating rule basically says that answer quality for the current iteration can be estimated from its value in the previous iteration and the reliability of workers who have provided those answers. And similarly, the updating rule for the worker reliability basically says that worker reliability can be computed from its value in the previous iteration and the number of correct and wrong answers as indicated by the current answer quality model. Okay, now I will introduce the experiments that we did on two domains, which are fetching and information technology. We collected about 1,000 candidate influencers for each of them in less than 10 hours, which is super fast. And note that the sparsity of the worker answer matrix is very high, more than 99%. This is because that it's very uncommon that two workers provide the same name, right? Which makes the worker answer matrix very sparse. And to collect the ground truth, we interviewed several leading companies that connect brands to social influencers. And from them, we construct a guideline by following which we label 40% of the candidate influencers. And then for evaluation, we use accuracy and area under the precision recall curve. Note that the area under the precision recall curve is more suitable in our case because we have more suitable than area under the ROC curve because we have imbalanced data set here. We have more actual non-influencers than real influencers. And for comparison, we first compare against those Boolean aggregation methods, which takes into account different factors in the annotation process, including, for example, worker reliability and some Bayesian method as well, work reliability with priors and task difficulty. And actually, one of the methods that I compare here, ZinCrowd, is a work by Janelle. And we control, and in the experiment, we control for the percentage of expert labels used in the model training. This we refer to as the supervision degree. And note that all the methods that we compare here, including ours, are trained in a semi-supervised setting, meaning that the expert labels are fixed in the learning process. So from the results, we observe that, okay, first of all, OpenCrowd improves the state of the art significantly. And we see that when supervision degree increase, when we use more expert labels, the performance of our framework also increase a lot, which is not necessarily the case for the other comparison method. Well, this is mainly because of the machine learning model used in our framework, which could leverage the similarity between the candidate influencers for propagating correct labels. And in the end, we found that more than 87% of the real fashion influencers are discovered through OpenCrowd. We did some extra comparison against the feature-based methods. So those methods that based on that also leverages a machine learning model in the aggregation. And apart from those, we further compare with some even simpler baseline methods like logic regression and MLP, multi-layer perception. Note that the difference between those feature-based methods in the literature and those simpler methods is that those feature-based aggregation methods, they further model worker reliability like we did. So results show that, okay, first of all, OpenCrowd outperforms the second best method, again, significantly. And a very interesting observation here is that the second best method are those ones that actually model worker reliability as well. So this further verifies that it is very important in this context to model worker reliability. And another observation is that it's easier for our framework to find information technology influencers than fashion influencers because the workers that we have engaged with are those ones that know more IT than fashion influencers. Okay, some takeaway message. We introduced OpenCrowd, a human AI collaborative approach that combines the machine learning model with worker reliability to identify social influencers. and we demonstrate that it substantially improves the state of the art. OpenCrowd is actually easily generalizable to other open-ended answers aggregation problems, even when the answers provided by the workers are free text, for which we can simply collapse the text into topics, for example, and then apply OpenCrowd. If you are interested, we can discuss more about that. Okay, cool. Thank you for your attention. We have a online code repository in GitHub. If you want to try it out, you can simply download the code. And thank you.
All right, thanks a lot, Jay, for the presentation. So we can switch now to the Q&A phase. So do we have questions in the room? We can start with that. Leila, go ahead.
Yeah, thanks so much for the presentation, Jay. So this is very interesting. And as you were presenting, I've been thinking about how some of the things that you have learned through this research can be potentially applicable to Wikipedia and the needs of Wikipedia as an online encyclopedia. This is kind of an open-ended question, and I would love to hear your thoughts in this space. One particular thought I had as I was listening to you is finding expert contributor can be a similar problem to what you're looking at, although we really don't have access to a social network of expert contributors with influence capacity. So if you're using the social media component of the platforms that you're using, that may not be particularly available in the case of Wikipedia. But if you have any thoughts, reflections on how this can be relevant or useful for Wikipedia, that would be great if you share it.
I'm actually not quite familiar with how Wikipedia uses experts. No, sorry, not uses, but uses their help from experts. I guess you do rely on experts in the moderation and content moderation. Is that correct?
I can maybe expand on this a little bit more. So the way experts can come in, and when I say expert, I'm actually, in my mind, I'm particularly focusing on experts in particular fields of study, right? So let's say in physics, mathematics, I'm thinking particularly right now about academics, but they can also be non-academics. So the one question is how to attract, how to find contributors in this space. In the case of knowledge that is already being documented, let's say, and shared in the academic conferences, this is relatively straightforward. You almost have a network of researchers that co-write papers with each other. So once you find one, you can find the connections to the other researchers. But let's say in the topics that are being less documented or less researched, let's say we know very little about who are actually the experts in this space. And there's a need to be able to identify these experts and use basically empower the crowd to notify us about who these experts are, where they live, how we can reach to them. Examples of it you can think about, for example, linguistic experts in different languages of Africa. This can be one example.
Mm-hmm. I think maybe a key problem here is, okay, first of all, how to find the right crowd, right? Then I think that should be perhaps easier than finding a source of experts. So one platform that I can think of now is Reddit. Right, Reddit. There we have sub-communities focused on specific topics, and those users, if they want, they can actually contribute to Wikipedia. And then in terms of how to find them, well, we can directly post questions in Reddit, or something that we can do is, again, using platforms like Mechanical Turk. And I guess it's okay to contact those experts directly in Reddit. But that's one platform that I can think of. And I mean, once you you know where to which crowd to ask, and you know how to contact those experts, then OpenCrowd, that the method that I presented, can be used in between, right? Once you get answers from the workers, you can start trying to discriminate real experts from the others, and then start the recruitment or any other way that you have to engage them in the contribution to Wikipedia.
Okay, thank you.
Just a reminder that we are also taking questions from IRC and the YouTube live stream. So if you have pressing questions and you are there, please post that Martin will relay them to us. I do have a question, if I may go next. So I was wondering, G, if you can tell us a little bit about, if you want to increase a little bit the quality of the results, could you incorporate in your model a sort of verify step? These kind of patterns in crowdsourcing where you have, the crowd first give you a set of raw answers, and then you have a moderator or someone who has more kind of an administrative control can just vet the answers that you gather from the crowd. Would that be easily incorporated in your model?
I'm not sure if I hear you very clearly. So what you were asking is if not, we can leverage some input from moderators, or those ones that perhaps can also offer some judgment on the reliability of workers. Is that right?
That is right, but I'm not necessarily referring to only Wikipedia use case, but also for crowdsourcing. So that would be like a second stage, like vetting, or you just ask the expert crowd to tell you whether the input was correct or not.
Actually, yeah, the framework that I presented can readily use expert labels, and we can actually do something extra. For example, we can ask the crowd, to vote for each other's answers, which could be a new signal to help the model to learn better. So there are different ways that we can actually try to improve further the model performance. And yeah, you're right. There are actually more use cases than perhaps only perhaps considering it in the Wikipedia, or maybe further we can actually go beyond the crowdsourcing, right? For example, all those online QA platforms, they can use similar methods, and perhaps also the peer review process might be able to be improved by this method, right? Because there we have reviewers who are, giving judgment about the quality of papers, and we can. This is something that actually we are currently looking at to see how OpenCrowd could help in improving the review process, especially given that conferences today, some conferences are getting quite big, and there are reviewers who might not be able to, who might not be qualified enough, right? So OpenCrowd can also help in that case. I might be diverging too much, but does that answer your question, Janelle?
Yes, it does. Thank you.
Okay, cool.
Do we have other sub-questions from the room? I think there is nothing coming from IRC and YouTube. All right, then I will just ask a follow-up question. So in terms of trying to cover more space, of trying to identify influencers in Twitter, for example, so can you tell us a little bit about the interface that you utilize? Like, are there some kind of tricks to design such a task that is not just, name your top 10 influencers? Can you kind of try to tweak a little bit the interface to cover more, or to gather more input from the crowd?
Yeah, that is. I think that is actually not only possible, but sometimes necessary. So in the interface that we created, we not only asked them to um, provide names that they know, right? So we did something extra. One thing is to further control for the quality by, for example, automatically checking if the names that workers provide do exist in the social media, and to further, engage them in this task, we ask them questions like how often they interact with influencers in social media, which could potentially help them, to get retrieve their memory about who are the influencers that they have interacted with. And what we also did is ask them to see their expertise, right? To evaluate their expertise themselves about the domain, which is something, some extra signal that could be helpful in the learning of OpenCrowd. Yeah, those are the things that we tried.
Sounds good. Yeah, there are many things that can be tried there. And I was just curious
Exactly.
to tackle this problem because of the huge space that you are trying to search.
And now that I think a little bit more about that, what we also did is to allow them to to chat with each other, but that in the end it didn't go very well. We still needed to see what would be the best way. I mean, allowing workers to discuss could potentially further improve the quality of the answers that they give. So if anyone is interested in that direction, we can discuss further offline.
Very cool. Do we have some other questions from the room or from IRC YouTube? All right. In this case, let's slowly switch to our next speaker. Thanks again, Jay Yang. So now we have Estelle Smith, who is a PhD candidate at the University of Minnesota. Estelle will discuss how our community helps in maintaining ORES, which is the machine learning system that predicts the quality of Wikipedia applications. Estelle, please. Okay.
Okay, hello. I hope everyone can see my screen now. So please let me know if you can't. But yeah, my name is Estelle Smith, and I am a PhD student at the University of Minnesota. I'm really excited to be here today at this research showcase. The title of this talk is Keeping Community in the Machine Learning Loop. And if you want to talk to me more about this work after the talk, you can find me on Twitter at me, myself, and HCI, or my talk page on Wikipedia is at phoneme. So before I get started, I just wanted to point out that this paper was just published a couple of weeks ago. And I wanted to explicitly thank all of the participants who contributed to this work, as well as my co-authors, Bowen, Anjali, Aaron, Lauren, and Hayi, a couple of whom are already on the call right now, we might hear from later. But their work was completely instrumental to making this possible. So thank you to everyone. And you can find a copy of the manuscript at the download link below. Okay, so the theme of this research showcase is human-in-the-loop machine learning systems. And these types of systems typically have three components. So the first is some type of a repetitive task that generally needs to happen in either an ongoing or a real-time context. For example, patrolling Wikipedia for vandalism. The second component in these types of systems is some kind of an algorithm that's going to semi-automate the task. But before we complete the task, we loop in a human because the general assumption is that human judgment is always, well, not always, but the general assumption is that human judgment is better than machine judgment. But there is a problem with this because in any one individual instance, there's one human who is making a decision. However, the outcomes of that decision can affect the entire community. And there are different stakeholders in the community. Different stakeholders potentially would make different decisions given the same possible choice in front of them. So the question that's motivating this work is how do we make sure that we're keeping the entire community in the loop here? Which is to say that we know that these types of systems can have impacts on human behavior. And the impacts on human behavior in turn affect the outputs. So we want to make sure that the systems are actually reflecting the values of the entire community rather than only individuals. So how are we currently moderating content that's generated on Wikipedia? There are both machine learning based and non-machine learning based pipelines that are used to revert damaging edits. So for example, if something is clearly vandalism, bots can come through and remove it from the site within a few seconds or almost instantly. Then there's these semi-automated review processes, which is mostly what I'm going to be talking about today, which take a little bit longer, so maybe 30 seconds to a couple of minutes. But there's also completely non-machine learning based systems, such as the watching pages, which doesn't have anything to do with machine learning. So one of the problems with this, though, is that when people get their edits reverted, it can damage their motivation to contribute again. So especially newcomers are vital to the success of Wikipedia as an organization for the growth and flourishing and diversifying of content. But if they're getting turned away by some of these machine learning based systems, that's a major problem for the community. So machine learning systems always carry with them some kind of a risk of unintended consequences. And the question we're trying to answer is, how can we build these types of machine learning or artificially intelligent systems for Wikipedia without harming the community? So I'm going to talk about this in the specific context of ORS, which is the Objective Revision Evaluation Service. And that's the last time in this talk I'm going to use those 4 words because it's too many words. And instead, I'm going to use this little robot guy to indicate when I'm talking about ORS. So ORS is a real system that has been online since 2015, and it's deployed in, I think, 42 different Wikipedia language versions. It's a collection of machine learning algorithms that is accessible as a web service and API to generate predictions in real time. And what does ORS do? So ORS generates predictions about edit quality, individual edits, whether they are likely to be, for example, damaging or high quality. And also something about the intention of the user who made that edit. Was this person intending to do a good edit, or were they actually a vandal who kind of had bad intentions coming to the site? I'm mostly going to talk about edit quality in this talk, but ORS also generates predictions about draft and article quality and topic. And ORS is deployed widely across a huge variety of contexts in Wikipedia. So the 2 I'm most familiar with and which are very common are the recent changes page, which is a live stream of edits as they're coming into Wikipedia, where patrollers will frequently look for damaging edits to revert them. Another tool is Huggle, which similarly allows patrollers to hunt down and revert edits. But there's about 30 more applications that are listed at this URL here. So we couldn't possibly talk about all the different examples of ways that ORS is integrated. But generally, it looks something like this. So we have edits that are coming in from anyone on the internet, and they look like these little gray circles, unknown quality at that point. The second that the edit is submitted, ORS takes a look at it and it generates a guess. So all these green ones are, we pretty much think that these are okay edits. These are good. We should let them stay on the encyclopedia. But there's a subset of these edits that we are pretty sure are damaging and probably should get rid of right away. And there's another set of edits that are a little bit less clear for a machine to be telling, is this good? We kind of need a little bit of human judgment to review this. So typically, humans are looped in at the end after ORS has taken a peek at the edits, and humans are typically given the ability to make changes to the content or revert the content based on ORS predictions. Okay, so I'm going to return to this question: is how can we keep community in the entire community in the loop as we're designing these ORS-based systems? So we used a method that's called value-sensitive algorithm design, and I'm going to refer to it as VSAT moving forward. So VSAT is based on a very long-standing method in human-computer interaction called value-sensitive design, and it has 3 major parts. The first part is to understand stakeholder values early in the design of systems. The second is to use these values to guide algorithm design. And the third is to evaluate algorithms not only based on their accuracy, but on how well they're satisfying the values that we have pre-specified. And this talk is mostly going to be about understanding stakeholder values, but I'm also going to talk a little bit about the second point. So we used qualitative methods to gather in-depth perspectives across 5 community stakeholder groups. So a very different data type than what Ji was looking at. And we used specifically semi-structured interviews to do this. So we had 16 participants, including ORS creator himself, 2 volunteer open source tool developers. We had 4 participants from Wikimedia product teams. We had 7 editors, as well as 2 researchers, because researchers are also routinely relying on output from ORS to do their bread and butter. And we asked questions like, What's your role on Wikipedia? What types of experiences do you have related to ORs? So that might be using ORs as a patroller or as a researcher. It might mean building tools for ORs, or it also might be simply just being affected by an action that was taken from an ORs system. We also asked people about their opinions or their ideas for the future. And we analyzed this data using grounded theory methods. So what this means is that we gather transcripts of the interviews and we look at every single line of the transcript and apply a code to it using our human judgment. We have a series of immersive group meetings to cluster those codes. And finally, we discuss and iterate on the themes until we're relatively sure that we have some themes that are representing accurately what our participants actually talked about. So these are the results of that grounded theory method analysis. We had 2 creator values that were relatively unique to the people who are responsible for building and maintaining ORs. And we had 5 convergent community values. I'm going to talk a little bit more later about what convergent means. And because of time limitations, I'm not going to talk about all of the values. If you see a value that's grayed out on your screen, you can learn more about that in the paper, but I'm not going to mention it during the talk for time limitations reasons. Okay, so we had 2 creator values, and I'm going to talk about the second one, which is to facilitate experimentation. So this is a quote from the creator of ORs, who was talking about his motivation and when he actually built the system, what he wanted to do. What I really hoped to see wasn't that we would do quality control better exactly, but that more people would start experimenting with quality control tools. So yes, we do want to work on quality, but also there's this element of like, how can we up level and provide even more opportunities for the Wikipedia community to really improve and maintain itself? And this quote was echoed by another Wikimedia Foundation employee who said, we need to build a contribution platform that allows people to plug their own algorithms in. So ORS is a specific set of algorithms, but at an even higher level, there's an interest from Wikimedia employees to expand this and make algorithms generally more accessible or easier to plug in. Okay, so then we come to these convergent community values. And why am I calling them convergent? So there's a possibility that different stakeholder groups have totally different values and that these values are in clash with each other. But actually what we found in our data was that the different stakeholder groups converged on what they found to be important. And we didn't really find any conflict between the stakeholder groups. But we did find that there's some intrinsic conflicts between the values themselves. And I'm going to provide some examples of those a little bit later. So these are the 5 values that came out of our study. And I'm going to talk about 1, 2, and 4. And I'll get started by talking about effort reduction. Effort reduction is the most obvious of the values that we talk about. And when I say this, what I mean is that we need to be reducing, or ORs and ORs-based systems should be reducing the effort of community maintenance. So here is a quote from a developer who said that if we can leverage the manpower that we do have with more automation, these people will have less backlog and can focus on other contributions, right? So it's not that these things don't need to get done, they do, but people also have other things to do. So it's really important to make sure that we can make the work of patrolling, for example, easier. Human authority is a major value that we actually posted this to the Village Pump and got feedback from the community before we published this paper. And everyone was saying that this is one of the most important ones. So human authority means that ORs and ORs-based systems need to maintain human judgment as the final authority. So here's a quote. OR's purpose is more to create lists of possible problematic pages or edits for human editors to look at, rather than to take action fully automatically. And there's kind of multiple levels at which you can think about this. One, you want humans to actually be able to control the system, but you also need to make sure that humans are using the system appropriately and not over-relying on the system. So here's another quote. I wouldn't rely on ORs 100% of the time. I would still have to use my brain to make a decision. So there's a problem that people can actually come to automatically accept algorithmic output without thinking about it enough. So that's a potential risk of these types of systems. And we need to be careful about how we design them to make sure people are still using their brains. Okay, now I'm going to talk about positive engagement. So this value means that ORs and ORs-based systems should be encouraging positive engagement with diverse editor groups. So we have a quote from a researcher who said that, I think that article quality is driven to a large extent by the diversity of hundreds of users. So in other words, we need to make sure if we want articles to be high quality that we have diverse people who are contributing. And this means newcomers, this means people from underrepresented geographical regions or underrepresented language editions. And it means diversity on a whole bunch of scales. And there's this problem on Wikipedia that there's a certain type of an ecosystem that exists, and that ecosystem works really well for the people who are already on Wikipedia, but it doesn't necessarily welcome a lot of diverse people equally. So this is a quote from a Wikimedia employee who said that the current ecosystem of Wikipedia limits the diversity of the contributors. So the ecosystem needs to change in order to become more welcoming to certain kinds of people. So if you're interested in this particular topic, I have some specific recommendations about how algorithms play into that, but we can get to that in the Q&A if people want to. So these are the 5 convergent community values that came out of our work. And, but there's this big question about like, well, what does it mean, or how can we practically use these values when we're building systems? So there's 25 specific recommendations in the paper that I would recommend checking out if you're interested, or if you want to build new systems on Wikipedia. But the basic idea is that we need to consider these values at every phase of algorithm development. And we also need to aim to balance value conflicts. So there's explicitly looking at these values and trying to make sure that we're navigating the trade-offs in a way that's respectful of the community values as a whole. So this is one of my favorite examples from the paper, actually, is that we have this big tension between effort reduction and positive engagement. So it's easiest to just wipe an edit away and not come back to it, but that can have negative impacts on newcomers, right? So, and it can make sure that people who are diverse don't have great experiences. So this quote I'll read the quote for you. Because we do everything in real time right now, it's very reactive and very combative. If good faith editors do something and a few seconds later, they immediately get a reversion notification, maybe those cases can be done later. What's the worst thing that will happen? Maybe somebody will see a syntax error for half an hour, or maybe even a day. That's maybe not so bad. So I want to point out that this is explicitly coming into conflict with some very well-established paradigms on Wikipedia, such as the bold, revert, discuss. It's suggesting that maybe we should wait a little bit while and consider what are the trade-offs that are actually going on here in order to make sure that that well-intentioned newcomer is not going to leave the community right away. And there's actually this, I like this example so much that I wrote an entire blog post about it, so you can go check it out at this link. There's 3 levels that we can think about as we're integrating these community and creator values. Excuse me, sorry. And the first level is I'll use the 2 values of human authority and effort reduction specifically. Ideally, we would be considering all 5 of them, but again, there's a limitation in terms of time here. So I'm just going to talk about 2. So the first level is the level of the algorithm. So if we're thinking about human authority and effort reduction, well, the maximal way to reduce effort is to have the machine do absolutely everything. Great, now the editors don't have to do anything and we've saved them the most time. But the problem is that that comes into direct conflict with human authority, because we also want to make sure that people are having an input and a say and are being the final authority on these decisions. So when we're thinking about the algorithm that we're selecting to build a particular type of tool, we can tweak algorithmic parameters in interesting ways to make sure that they're suiting our goals. So in this talk, the positive judgment by ORs is equal to a damaging edit, and a negative is equal to a good quality edit. So let's say that we want to build a counter vandalism bot. Then the goal of that counter vandalism bot is going to be find bad edits and revert them. False negatives are a case when a bad edit is not caught. And so minimizing the false negative rate can help to make sure that ORs is not inaccurately predicting that things are good edits when they're actually bad. So that's one example. Another example is, like, let's say that our goal is to do semi-automated edit review, like the examples that I've been talking about. Then what our goal is to not revert edits that are actually good edits. So we want to be able to minimize the cases when ORs is incorrectly predicting that a good edit is bad. And we can do that through minimizing the false positive rate. And this last example is a little bit longer, but just like above, we want to make sure that if we're talking about specifically, we want to build a tool that's helping with newcomer protection. So maybe we can minimize the false positive rate in the sense that we still want to try to catch all of the bad edits, but we give a little bit more wiggle room here so that the newcomers aren't getting protected. We can set the overall error to less than 0.1. Okay, so that was specific nitty-gritty related to the algorithm itself. But we also have user interfaces that people are seeing. Most users are interacting more with the interface than they're interacting with the algorithm itself. So what does this mean? Well, one thing that we can do is get better at visualizing and allowing people to interact with the algorithm itself. So making it much more clear, what are the inputs to this algorithm and what are the actual outputs of the algorithm? And we can show more information about the predictions and demonstrate that actually these systems do make errors. And it's important for people to keep that in mind, for example, so that they don't come to rely on it too much. So basically building better tools and using the interface to communicate important information in transparent and accessible ways. And the last level that I'm going to talk about is the work process. So, and this is pretty high level. We can talk about it more in the discussion if we want to, but currently this kind of represents what happens is that we have these three processes and they're sequential, right? So we have automated bots that revert very highly likely to be damaging edits. Then we have semi-automated review. And maybe after that, somebody will reach out with a socialization tool. This is kind of what can happen now on Wikipedia, but there are ways we might think about changing that if we wanted to better serve community values. So, and I'm going to end on this note, and I believe, yep, we're doing okay on time. So we heard from a couple members of Wikimedia Foundation that one of the values that's important is facilitating experimentation because we want the community to be able to grow. But the problem with experimentation is that it's even more likely to have unexpected outcomes than a very carefully considered system that's taken a long time to develop. And there's this risk that when we experiment too much, we can violate any one of, or even up to all 5 of these community values. So we have to be really careful as we're designing these experiments that we think about these values. And this is a final quote from the creator of ORS, that we definitely don't want to put barriers between people using ORS, but if you can use ORS, then you can also use it inappropriately. So I just wanted to kind of leave the talk with that to think about and see what people wanted to discuss. So thank you so much. And if there's any questions,
excellent. Thank you, Estelle, for this great presentation. So once again, let's see if we have questions from the room and also from IRC and YouTube.
I can go, maybe. Estelle, thanks so much for your presentation. Really interesting work. So one question I had for you, and maybe I have a follow-up comment question, is did you do the data collection for this research primarily on English Wikipedia and for English Wikipedia users?
Yes, they were primarily English Wikipedia. There was some diversity in terms of like some people were in Europe, some people were in the States. We did have one participant who was who phoned in from Africa, which I really appreciated hearing his perspective as well. He was a relative newcomer and really passionate about building more content in underrepresented area. So, but it was primarily English-speaking Wikipedia.
Got it. So it would be very interesting to see how this changes, and I don't mean to create more work for you, but only if you're interested, to see how this changes as we go to medium-sized languages or smaller languages. For in some of these, so I'm particularly right now drilling down on human authority as one of the values, and I wonder in the languages where we have some contributors, bot contributors, and there are languages for which we basically don't have any patroller who speaks the language. How does the community, the smaller community of this language, think about human authority and the role of ML? And I would not be surprised if the answer is that depending on the size of the community, the availability of different resources, these values change, or at least kind of the trade-offs that you want to make on these values as you go from community to community changes. If you have any thoughts on that, or speculations are also fine, I would love to hear them.
I think that's a really interesting question. And I think it's a really important question. So just one comment in general is that, it's hard to recruit people to complete an interview with you. And in an ideal world, we hear from every single stakeholder and we can kind of, figure out based on that, like, okay, this is legit the whole community. It's kind of a limitation of qualitative methods that we can't do that type of a thing. But I do think it's really interesting and would be worthwhile in some of these communities where there is the most need to talk to a few people who are getting involved and find out how do they balance these values. And I suspect some of the same thing that you mentioned, which is that it might be the case that in order we make the priority of like, I'm not seeing, you know, one of the things that didn't come out because of the selection of participants was that, you know, generating content from nothing wasn't kind of a value. We already have such a huge content base in English Wikipedia that maybe those gaps don't exist. So I think it's very astute to point out that there may be different values, and potentially having human authority is still a value, but less important than the higher level value of like getting that content out there. But the only people who are capable of making those types of statements are the users who have that stake there. So I really can't speak to those users, but I would imagine that what you said is a reasonable guess.
Okay, thank you.
Yeah.
I believe we have some questions from IRC.
Yeah.
Martin, you want to go ahead and...
Yeah, I can relay on. There's a question whether you plan to measure user reputation by measuring the quality of the edit.
Yeah, so this actually, I didn't talk about this in the talk at all, but the final value, the community trust value, was one that I thought there were some fascinating recommendations, and really go check out the paper to read about this. But this last value, community trust, established the trustworthiness of both people and algorithms. So it's not just that we need to establish trust in the algorithm, it's that sometimes the people who gain reputation on Wikipedia have to do so currently through these highly manual processes that rely on consensus forming and, you know, doing deep dives into their history to see, like, have you always been a good Wikipedia editor, or was that one time you did this thing that was kind of unsavory? Or and one of our participants actually suggested that we could build tools that use machine learning to probe the history of editors and see, like, are you likely to be a good contributor? There actually were a number of participants talking about how we think it would be valuable if there were automatic ways of understanding how good individual members of the community are. And some of that is based on contribution history. Some of that might be based on your talk page. Some of that might be, you know, based on things that aren't even happening online. So it is definitely something that our participants expressed a lot of interest in. And simultaneously with looking at the reputation of people, we need to look at the algorithm itself, right? And make sure that we're finding ways that we can be confident that we can trust it. So what is the data how is the data getting labeled? How, you know, who are the people that are labeling the data? You know, it's kind of a little circle that we need to think about very carefully. And again, in the discussion, when we posted these values before publishing the paper, this one, people were like, yes, we need community trust, but this is also really hard to get it right. Because yeah, how do you quantify trust, right? There's a whole research discipline dedicated to that. But yeah, thank you for the question. I hope that got at some of it.
So I actually have a related question. So the idea of allowing more interactions to happen between community members and the algorithm is actually very interesting. So the problem with the automatic algorithm is that sometimes they suffer from this severe issue of unknown unknowns, mainly due to the biases in the training data. Right. So and those biases sometimes is not aware by the developers who make those algorithms. So I wonder if there's any research that have analyzed those biases by engaging with the community. I mean, perhaps for this specific case of edit classification and maybe any other related tasks.
Yeah, I'm not familiar necessarily with research in that space. I know that I have heard of some things that are happening related to bias in Wikipedia at large, in terms of the type of articles that are getting written and the type of people that are contributing maybe. But it's a really good issue to look into a little bit more. And you mentioned something at the beginning of that comment. I'm gonna actually just go to, let's see if I can find it. Oh my goodness. Right, so here are some interesting thoughts that when we're thinking about positive engagement between people, you mentioned that, you know, you don't even know sometimes when an algorithm is biased, right? And I think this is why it's really important to understand, especially through the UI, communicate this to people as they're using the systems, which actions were taken by humans and which actions were taken by AIs. This doesn't totally solve the problem, but it at least can help us to grapple with it on some level, because we can see where the bias might be introduced. And there's some other very interesting comments here around, for example, socialization, right? Algorithms can show up and kind of, there's the potential that they can destroy social structures that exist in the community. And we want to make sure that instead of getting rid of those, we actually facilitate increased socialization. So I think some of these suggestions that are in the paper can start to speak to your question, but not entirely answer it, but.
So maybe I can also respond to that question. So I have been working with some CMU undergraduate students to start looking at some, auditing our systems. So for example, the initial analysis showed that, for example, there are the our system have the accuracy of our system are different across different editor groups. So someone to put it is like the ORAS is more accurate when they classifying the experienced editors edits compared to classifying, for example, newcomers and anonymous editors. So, but it's not necessarily it's a bias. It's so we are working with Aaron and working with community members to really understand community's interpretation of this performance, different performance across different editor groups, and to figure out to work on how we should whether we think that's a problem or not. Maybe it's not a problem. So maybe the community. The experienced members are the most valuable people in the community, and then they are more trustworthy. So maybe it's not. Maybe Aaron can speak about it. So I think this is so. In general, I think we might not want to directly apply, for example, some of the fairness in machine learning, the result directly to the Wikipedia's context, because Wikipedia has its own community value, has its own community norms. So we really want to engage communities in terms of understanding how we should design our systems for the community.
Thanks.
Aaron, did you want to chime in on that as well? I'm not sure if his mic is on.
Aaron, are you around?
Oh, so sorry. I think I was frozen a little bit. Did I?
Okay, let's take another question from IRC, and then we can come back to Aaron if he's around.
Sure.
There was a question from the YouTube chat whether I tried to quote whether this process can be made, or the method to be made, context aware. And the example is whether some users could be more influential when working on particular topics. So I don't know if that is something that, how much you work on ORAS itself, or if that is something that came out in the interviews about these type of possibilities to make this variable.
I'm trying to make sure I understand the question. So we want to make the system more context aware by allowing certain individuals to have more say. Is that, am I understanding?
I think I'm trying to relay it on from what I can see is that I think it's that there are some systems to recommend specific articles to topics to edit. And if these type of quality systems, I mean, in some sense, it is already taking into account, or there are different levels of user rights. But if that is something that came up perhaps in the discussions to how to tune that or how to influence that, these types of control mechanisms on taking into account the context of the user or the topics they work on. And so on.
Yeah, so definitely it came up in the interviews. Some of that, for example, and I'm thinking about a specific section in the paper where we're talking again about workflow support, which is another value that I didn't talk about very much in this talk. But for example, one of our interviewees was talking about how their entire workflow was based around the types of topics that they like to look at. So, and right now, the way that, I understand that there's topic modeling tools that exist. In fact, ORS has predictions on these, but I haven't heard as much about tools that are using those topic models. And I'm sure that they're out there. So this is mostly, I invite participation from anyone else who knows more about that than I do. But this particular user was not aware of a tool that could help him to look through edits or look through articles that were things that he was interested in looking at. So he had this really clunky workflow where he would go and search, specific school names or things like that to find schools that had recently edited pages and try to make sure that those schools were not being vandalized by teenagers, because it was important to this person to do that. And in that sense, the workflow support section specifically of this paper is talking a lot about the context. So the context in which individual patrollers are using ORS tools and the specific preferences that people have in order to make their goals get met. So, and some of the suggestions in the paper around that are looking at like, how can we configure these things, or how can we provide options that make the workflow easier for those specific contexts? Because the easier we can make it for people to do this work, the more work is going to get done. And people will just be happier and maybe less stressed out as they're going through it. So I hope that kind of addresses the question. And I think it looks like Aaron's mic might be back on. So if you want to come back and speak to that previous question.
Yeah, can you hear me all right?
It's a little quiet, but I think we can do it. Yeah.
I'll be closer then.
Yeah.
Thank you. Thanks for your patience on that. Well, actually, let me address this question first, because I think this is a really good question too. We actually use people's user rights as predictors in the model. And that came from a direct community request that they didn't want. They wanted us to hard code the model to not flag edits by administrators. And rather than hard coding it, we instead included administrator rights as a feature in the model. And that ultimately ended up basically hard coding that it wouldn't make damaging predictions about administrators' edits. That's an interesting trade-off though, because it also causes a bias in how the system works. So that brings me back to this discussion of bias. So there are a bunch of different studies that we're engaged in right now looking at bias. We want to know if there's bias at the level of the algorithm. We want to know if there's bias resulting in Wikipedia that moves beyond the algorithm and how people actually use the algorithm in practice. There's some fun work that one of my collaborators is hopefully submitting to CCW in a few weeks that will be exploring like downstream effects on anonymous editors and new editors when we release ORS in various wikis. But one process that I want to call your attention to that I think is really fascinating that we do that I don't see much else in the world of sort of algorithmic decision support is we encourage our users on various wikis to perform audits of ORS. Essentially to flag false positives and false negatives, explain to us what was going on. And these essentially turn into bug reports of where the algorithm is consistently missing the mark. In some cases, that's because the algorithm is biased against a particular set of users. In other cases, it turns out that we made a mistake when we were writing a feature extractor and it was extracting a feature incorrectly. But this mechanism of asking community to audit the algorithms in collaboration with us has proved to be a really valuable tool in detecting these kind of problems. So it's something that we're investing quite a lot in. We're building a better auditing system called Jade, but I'll leave a discussion of that for some other time.
Well, this is very interesting, actually. Are these algorithms used by Wikipedia openly accessible?
I guess I should probably take that one too. So the algorithms that we use now are openly accessible. The damage detection, like vandalism detection algorithms, are not really targeted towards sophisticated attacks. So we're not really worried about vandals looking at the algorithms in order to figure out a way around them. Once somebody's actually looking at an algorithm to figure out a way around it, they're not really who we're targeting with these sort of things. So right now, everything is absolutely open. In fact, if you want to rebuild our models from scratch, the whole pipeline for building them is well documented. It's basically turnkey if you can run some Python code. Yeah, yeah, and our repositories are open and that sort of stuff too.
Thanks. This is very, very interesting.
Okay, Leila, did you want to add something?
Just one quick comment, given Jay's interest in the bias conversation. Jay, you may be interested in looking into Wiki project countering systemic bias on English Wikipedia. I will put the link here in the chat for you. But given that you mentioned the unknown unknowns and kind of how to engage the crowd to flag sources of bias on the projects, you may want to look at that. The editors have done a really deep and fantastic job in capturing sources of bias and types of bias that exist on the projects. Happy to talk more offline if you're interested in this topic with you and others.
Thanks. This is very useful information for me. Yeah, I guess I also learned quite a lot from this, maybe more than what you have learned from my talk.
All right, if there are no more questions, I hope everyone enjoyed and learned from today's talk as much as I did. I think we were exposed to two very different ways of combining humans and machine learning. So on one side, we have this kind of paid crowdsourcing or mechanical Turk to bootstrap a machine learning system and gather labels, etc. But we have this challenge of quality that we have to deal with like sophisticated machine learning and mathematical models. And on the other hand, we can bring the algorithm actually closer to humans and to community to have them help in the design and in the improvement process of the algorithm. I find this type of dynamics very, very interesting. Okay, unfortunately, we are at time. Let me close out the May showcase first by thanking our speakers. Thank you very much, G and Estelle, for the great talks. Yeah, also to everybody in the audience, thanks again for tuning in. Have a great day, great rest of the day or evening. Goodbye.
Bye.
Bye-bye.